Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Invisible Dice. It's an easy problem. So what the problem states is that we have been given two fair six-sided dice. By that they mean that each side of the dice is equally likely, right? It's given over here in the note too, that for each dice, each face is equally likely to turn up after a toss. This line over here means. So it says that keeping the first one untouched. Let's call the first dice D1. That means D1 has a sample space of 6 as stated over here. So, but what happens with the second dice is, which is mentioned over here, is that usually it would be the exact same sample space as D1, but we have erased each face and written a new number of our own. So there's now 6 new values on D2 such that the sum of outcomes of the two dice, such that the sum of outcomes of whatever comes up on dice 1 and whatever comes up on dice 2, when we add these two, it has to be equally likely an integer between 1 and 12. So what does this mean? So and using this, we have to reduce the actual numbers that were over here in D2. What were the 6 numbers that were chosen for D2 in this modified dice? So usually when we've been given two normal dice, D1 and D2, and let's say both of them are completely normal, then what happens is we get a probability distribution of this over here. So this is usually the probability distribution for two normal dice thrown together and to plot the sum of the values against the probability. So since the question mentions that for this new dice, the probability of getting a number between 1 and 12, all integers between 1 and 12, 1 and 12 inclusive, is equally likely, well, we can deduce a few things from that. So that means that there are 12 options, right? All the integers from 1 to 12, and all of them are equally likely. And we also know since there are only 12 options, the probability of getting a 1 plus the probability of getting a 2 all the way to probability of getting 12 all must add up to be 1. And the question says that all of these values must be equal. So we can say that 12 into probability of x, where x is any number from 1 to 12, has to be 1. So we get that the probability of x is equal to 1 by 12. Or rather, we could say that the probability of getting 1 as the sum of d1 plus d2, or the probability of getting 2, and likewise all the way up to the probability of getting 12 as the sum of the faces of both the die, are all equal to 1 by 12. And this is really important. We can deduce a lot from this line over here. So you might think that, okay, D2 has 6 values that are unknown to us right now, and there's a lot of variation. So we can't really like narrow down on what should be the values of D2. But there's a trick you can use to really start to narrow down. And the trick is that since we've got 6 variables, and that means there's too many options, too many combinations of numbers, we try to find constraints to narrow down on the options by using extreme cases. First of all, since our numbers can only be between 1 and 12, you have to notice that any number over here in D2 can't be, so let's say any number is x. X can't be below 0 or greater than 6. So x can't be less than 0 and it can't be greater than 6. Both these cases can't happen, where I'm assuming x to be representative for all of the 6 values that D2 can take up. Now, why is this? Because if, let's say, x were minus 1 or less than that, then when it's combined with 1 over here, then that would give us a sum of 1 plus minus 1 equals to 0. And we know that every answer or every sum of the dice should be at least 1, or if not more than 1. And where the 1 is from over here, since it's the minimum case of D1, that means that the 0 should be the minimum over here. So x has to belong to 0. And the same reasoning goes for the case where I'm saying that x has to be less than 6. It can't be greater than 6 as stated over here. Because let's say x was 7. Now if x was equal to 7 and it would have to at least once combine with 6 over here in dice 1, that would add up to be 13. And we know that the greatest that is possible is 12. So we just deduce that x has to lie between 0 and 6, right? In order to make those 3 possible combinations out of the 36 total possible combinations where the sum is equal to 1. What I'm trying to say is whenever D1 is equal to 1, D2 has to be 0 3 times, 3 separate times. And that is only possible when D2 has three separate zeros in its total possible outcomes. And talking about the case over here where the sum has to be equal to 12, that means the probability of 12 has to be equal to 1 by 12. That means that out of 36 total possible options, 3 times we have to get a sum of equal to 12. And well, using the exact same reasoning. So since our values have to be between 0 and 6, and for any value, let's say at max I would take 6, it would have to take the max over here too, which would also be 6. So only using the maximum values can we get a sum equal to 12. And this has to happen 3 times. And we know that D1 only has 1 6, but we need D2 to have 6 3 times in order to create 3 different cases where the sum is equal to 12. So that means that D2 also necessarily has to have 3 6s. So that just leaves us with this possible outcome. D2 has to have 3 zeros in order to create 3, and D1 is 1 and D2 is 0. And similarly, D2 has to have 3 cases of 6s in order to create the 3 possible outcomes of sum equal to 12, where D1 and D2 both have a 6. So since these 2 cases where the sum is 12 and the sum is 1 constrain D2 to be this particular value, that means that this probably is the solution. And now if you were to try to calculate all the other probabilities, so probability of 2 and probability of 3 all the way to probability of 11, you would see that all of them are equal to 3 over 36 or 1 by 12. I hope you guys understood the solution, and thanks for watching.